Okay, this is Mr. Weideman, and this is Lafayette High School AP Physics, and we have a UT Quest problem that is forces in friction. And this is the one where I've got a large block that's pushing a smaller block, and it's pushing it with enough force that that smaller block stays suspended or floating on the face of the larger block. And I think they start out by giving you this diagram. Let me back up just a little bit. Okay, so what we have is basically this diagram, and it's got a big FP pushing it. And it wants to know how much force is necessary to do that. And then they give you a little bit more information. I think you got a mu static here that's between the blocks. And then you have a mu kinetic here. Let me change that to a K. Because it's sliding on the floor. And I think that's about all you're given. I think they actually give you the coefficient of friction. What I need you to note on this free body diagram is I have a couple of internal forces, reaction pairs. These guys right here are reaction pair. So what happens is one of these forces of friction, this guy is trying to suspend the block, whereas this guy is trying to, its reaction pair is pushing the first block down into the floor more. Okay, and this guy right here, we can deal with him conventionally. This guy we don't care about because it's acting on the floor, and we want to know what's acting on the block. All right, a lot of you started on this with the right path, but this is a complex problem. So what we're going to do is we're going to start out, and let's just do a free body diagram, and I'm going to have to separate them. And if you did a free body diagram of the first mass, that's okay. We can do that, but we're going to start running into problems real quick. First of all, did you consider this reaction pair? All right, this force of friction of the block on its face, yeah, it's holding the little block up, but it's also pushing the big block down. Which, okay, that's all right. I can account for that in my force normal. But did you think about this? Okay, that this push on this guy is going to be a reaction pair on this guy. All right, so, yeah, things get kind of ugly kind of quick here. So, this force normal on the block is going to become a sticking point. How am I going to solve it? Well, let's switch over to the little block and let's glean a little bit more information. Okay, this is one of the big things that's going to help us solve the problem right here. All right, this force of friction is going to be just enough to overcome the weight. That's all the acceleration I need. That's the only amount of normal force I need, is I just need to make that guy stick. No more, no less. All right, so that tells me I can actually get at that number. That force of friction suspending the small block is going to be equal in magnitude to its weight. And I can actually transfer that information over this free body diagram over here. Still doesn't solve my force normal problem. Back to the little block. All right, I'm going to have to get this guy. Well, if I look at the little block, then that is my F net that's going to accelerate my block forward. Okay, we're going to need that because if we're going to find F of P, which is the main thing that we're after here, we're going to have to know how fast we're accelerating this thing. And since the two blocks are stuck together, they're going to accelerate at the same rate. So that's going to be a really key information for us to have. All right, it gets a little tricky here, but stick with me. All right, force normal, we also know from our friction equation that force friction is equal to mu s force normal. So let me just solve this right here for force normal, it's force friction divided by mu s. And remember that this force friction guy that we're talking about right here, we already said his magnitude was the same amount as the weight of this block. So what we have here is we have an expression for force normal that I'm going to plug back into the second law equation that we first started with. And what this allows me to do is allows me to solve for acceleration. And that's going to be huge. Okay, now what I'm going to do is, if I wanted to, I could come back to block 1 and kind of figure things out. It's still going to be tough without that acceleration. So there's an easier way to solve the problem. Now that we know acceleration, let's go back to a free body diagram of the entire system. All right, now how is that going to help us? Well, first of all, now that we know the acceleration, and if we treat this thing as an entire system, some of these other little forces in here are going to cancel out. For instance, these guys are a reaction pair, and this force normal of the big block on the little block and the little block on the big block are also going to cancel out. So I can treat this as one entire mass, all right, which means I can find the weight of the entire system together. Okay, that makes my force normal easy. Those two are going to be congruent. I have this force friction due to the floor, which is a mu k force normal. I have everything I need to go to Newton's second law on this equation. And when I set this up, since I know acceleration, my only unknown is going to be the applied force. Therefore, I'll be able to solve for just the applied force. Kind of complicated. If you got this entirely by yourself, you did a great job. Like I said, many of you had a lot of right ideas, but pushing this thing all the way through is indeed a complex problem. All right, but you guys are good to go now.